Welcome to Video Creator. Today, we embark on a fascinating journey to explore the profound mysteries and unique anomalies of water. Water is everywhere, covering over 70% of our planet, yet it remains one of the most enigmatic substances in existence. Despite its abundance, water behaves in ways that constantly defy the conventional laws governing almost all other known liquids on Earth. These strange behaviors, known as anomalies, are not just scientific curiosities. They are absolutely essential for the survival of all life. Let us dive deep into the first of these incredible paradoxes, focusing on the highly unusual density of solid water. Unlike almost every other substance, water expands when it freezes, meaning that solid ice is actually lighter than liquid water. This seemingly simple fact has monumental consequences for our planet, allowing ice to float and form a protective, insulating layer. Because ice floats, it prevents oceans and lakes from freezing solid from the bottom up, preserving delicate aquatic ecosystems beneath. Without this crucial anomaly, life as we know it would struggle to survive in the harsh, freezing conditions of winter. At the molecular level, water molecules arrange themselves into a spacious hexagonal lattice when freezing, which decreases its overall density. When ice melts, this rigid structure collapses, allowing the molecules to pack more tightly together, making liquid water remarkably denser. This unique density property is just the beginning of water's bizarre characteristics that continue to puzzle scientists around the world. Next, we explore water's exceptionally high specific heat capacity, a vital trait that plays a massive role in global climate. Water has an incredible ability to absorb and retain heat without experiencing a significant increase in its own overall temperature. This thermal inertia allows massive ocean currents, like the Gulf Stream, to transport enormous amounts of warmth across vast distances. By carrying this vital warmth to places like Europe, water effectively moderates the global climate, preventing extreme temperature fluctuations everywhere. In stark contrast, areas without large bodies of water, such as vast deserts, experience drastic temperature swings between day and night. Coastal regions benefit immensely from the ocean's stabilizing effect, creating temperate environments that are highly conducive to human habitation. The immense energy required to heat water is due to the strong hydrogen bonds holding its countless tiny molecules together. Breaking these resilient bonds demands substantial thermal energy, which explains why water takes remarkably long to heat up and cool down. This heat capacity also fuels powerful weather systems, as the oceans slowly release stored solar energy into the dynamic atmosphere. Moving on, we encounter another astonishing property, surface tension, which creates a strong, invisible film across the liquid's top layer. This high surface tension allows lightweight insects to literally walk on water, utilizing the cohesive forces between the surface molecules. Surface molecules are pulled inward by their neighbors, creating a dense, elastic layer that strongly resists external pressure and penetration. This cohesive force is why water naturally forms nearly perfect spherical drops, minimizing its surface area to maintain maximum stability. Closely related to surface tension is capillary action, a vital mechanism that enables massive plants to transport water against gravity. Capillary action occurs when the adhesive forces between water and the plant's narrow vessels overpower the cohesive forces within water. This allows water to climb hundreds of feet up towering trees, delivering essential nutrients from the deep soil to every leaf. Without this remarkable capillary action, grand forests could not exist, and the entire terrestrial ecosystem would collapse into barren wastelands. While these classic anomalies are well documented, modern scientists are now uncovering even deeper, more profound mysteries hidden within water. Leading researchers, including Anders Nielsen, have proposed a groundbreaking hypothesis that challenges our fundamental understanding of this seemingly simple liquid. They suggest that liquid water is not a single uniform phase, but rather a dynamic mixture of two distinct structural states. This two-liquid state hypothesis posits a constant chaotic fluctuation between a low-density liquid structure and a high-density liquid structure. At ambient temperatures, these two distinct states rapidly shift and intermingle, making them incredibly difficult to observe and measure directly. To truly investigate this radical theory, scientists had to push water into an extreme, unstable realm known as the supercooled regime. Supercooled water remains completely liquid below its standard freezing point, but it becomes extraordinarily volatile and prone to instant crystallization. The slightest disturbance or impurity can trigger immediate freezing, making experiments in this ultra-cold zone exceptionally challenging and highly delicate. To overcome this immense hurdle, researchers turned to some of the most advanced and powerful technological instruments ever built by humanity. They utilized ultra-fast X-ray free electron lasers, capable of capturing atomic movements in mere quadrillionths of a single fleeting second. These incredibly powerful lasers act like the ultimate high-speed cameras, literally freezing the rapid molecular dance of water in time. The experimental setup required firing microscopic droplets of ultra-pure water into a vacuum chamber, rapidly cooling them through rapid evaporation. As the droplets flew through the void, their temperature plummeted to a staggering -45 degrees Celsius before instantly freezing. In that crucial millisecond before crystallization, the powerful X-ray laser pulsed, capturing diffraction patterns of the supercooled liquid's internal structure. The resulting diffraction patterns provided the first direct, compelling physical evidence supporting the existence of two distinct liquid arrangements coexisting. Analysis of the data revealed undeniable signatures of both low-density and high-density structural domains, fluctuating rapidly within the supercooled droplets. To confirm these astonishing findings, a parallel set of historic experiments was conducted at another cutting-edge facility located in South Korea. The international team of researchers utilized similar advanced techniques to probe the highly volatile nature of water at extremely low temperatures. Their results corroborated the Stanford experiments, further solidifying the revolutionary idea that water is indeed a complex mixture of two liquids. This discovery points towards a hidden liquid-liquid critical point buried deep within the deeply supercooled regime, fundamentally rewriting physics textbooks. The existence of these two fluctuating states perfectly explains many of water's bizarre anomalies that have baffled brilliant scientists for centuries. For instance, as water cools towards freezing, the bulky, low-density structure becomes increasingly dominant, causing the liquid to dramatically expand. But what do these profound molecular revelations mean for the complex biological systems and the very foundation of life itself? Water is not merely a passive, inert solvent inside our cells. It is an incredibly active and essential participant in biology. The unique structural fluctuations of water play a critical role in guiding proteins to fold into their correct, highly functional three-dimensional shapes. Water tightly surrounds and protects our DNA, forming a structured hydration shell that is absolutely vital for maintaining genetic stability and integrity. Some visionary researchers even propose that the dynamic hydrogen bond network of water acts as an incredibly fast biological information highway. Protons can travel rapidly along these fluctuating water chains, potentially transmitting essential cellular signals at speeds far exceeding simple chemical diffusion. This suggests that water might coordinate complex biological activities across relatively large cellular distances, acting somewhat like a microscopic nervous system. The deeper we look into a single drop of water, the more astonishing complexity and profound mystery we continue to uncover. From its bizarre density to its hidden dual nature, water's anomalies are the very specific reasons why our planet is habitable. It is the perfect, strange substance that beautifully orchestrates the delicate, incredibly complex symphony of life on our fragile blue planet. As we search for life beyond our solar system, we fundamentally look for the unmistakable signature of this miraculous, anomalous liquid. The presence of liquid water remains our absolute best indicator that a distant world might possibly harbor some form of life. Understanding water's deepest secrets not only explains our own existence, but also guides our ongoing quest to find life elsewhere. Yet, despite all our advanced technology and brilliant scientific minds, water continues to hold on to many of its deepest, most profound secrets. The hypothesis of two liquid states is incredibly compelling, but the scientific community continues to vigorously debate and rigorously test these ideas. Future experiments, utilizing even faster lasers and more sophisticated analytical techniques, are currently being designed to definitively prove this revolutionary theory. We are standing on the very edge of a completely new paradigm in our fundamental understanding of the most common substance. Every new discovery about water's intricate structural dynamics forces us to reevaluate our understanding of chemistry, biology, and planetary sciences entirely. It is a humbling realization that the liquid we drink every single day remains one of the greatest scientific puzzles ever encountered. We interact with it constantly, yet we are only just beginning to truly comprehend the hidden, complex, dual life of water molecules. Our entire global agriculture, massive industries, and modern societies rely entirely on the predictable yet highly anomalous behaviors of this crucial liquid. We harness its immense power, yet its fundamental microscopic nature continues to gracefully evade our complete and total scientific comprehension. Water is the ultimate connector, the universal medium that intimately links every single biological organism on this planet in a shared existence. It flows through our veins, filling our cells, acting as the dynamic stage upon which the complex drama of life continuously unfolds. The next time you drink a simple glass of water, take a brief moment to truly appreciate its hidden, incredible complexity. You are not just consuming a simple liquid, you are ingesting a highly structured, dynamically fluctuating network of life-giving molecular anomalies. The story of water is far from over. It is a continuous, fascinating journey of scientific discovery that challenges our deepest assumptions. As researchers delve deeper into the supercooled abyss, we eagerly await the next major breakthrough in understanding this miraculous, essential substance. Thank you for joining Video Creator. Let us now delve even deeper into the specific physics behind these extraordinary life-sustaining water anomalies. To truly grasp water's bizarre behavior, we must first examine its unique geometry, specifically the precise angle of its chemical bonds. This distinct, bent shape creates a strong electrical dipole, meaning one side of the molecule is slightly negative, the other slightly positive. Because of this polarity, water molecules attract each other relentlessly, forming a vast, sticky network of hydrogen bonds that dictate its properties. Unlike normal liquids, where molecules simply slide past one another, water molecules are constantly engaging in a rapid, complex molecular dance. These hydrogen bonds are incredibly dynamic, constantly breaking and reforming trillions of times every single second in a glass of room temperature water. This powerful, sticky network is exactly why water boasts an unusually high boiling point compared to other molecules of similar size. Without these vital hydrogen bonds, water would boil at minus 80 degrees Celsius, and liquid water simply could not exist on Earth. Let us revisit the density anomaly. As water freezes, the hydrogen bonds force the molecules into a highly ordered, spacious, hexagonal arrangement. Fascinatingly, applying intense physical pressure to ice can actually cause it to melt, a rare phenomenon heavily utilized in ice skating mechanics. The high pressure from the sharp blade temporarily collapses the spacious ice structure, creating a thin, slippery layer of lubricating liquid water. Water reaches its absolute maximum density at exactly 4 degrees Celsius. As it cools further towards freezing, it paradoxically begins to expand. This unique property ensures that deep lakes stratify during winter, with the densest, slightly warmer 4-degree water sinking safely to the bottom. This crucial thermal stratification provides a stable, relatively warm sanctuary at the bottom, allowing diverse aquatic life to survive harsh, freezing winters. However, this same expansive force is incredibly powerful, easily capable of bursting thick metal pipes and slowly shattering massive solid boulders. This freeze-thaw cycle is a primary driver of geological weathering, slowly breaking down massive mountains and actively shaping the Earth's rugged landscapes. Another peculiar trait is water's viscosity. Unlike most liquids, applying high pressure actually makes cold water significantly less viscous and flow easier. Intense pressure forcibly distorts the bulky hydrogen bond network, partially breaking it down and effectively reducing the internal friction between the water molecules. This strange behavior has profound implications for the extreme, high-pressure environments found deep within the ocean's most mysterious, unexplored abyssal trenches. Water is famously known as the universal solvent, capable of dissolving more diverse substances than any other liquid commonly found on Earth. Its strong polarity allows it to aggressively surround and separate charged ions, completely tearing apart solid crystalline structures like common table salt. This exceptional dissolving power is absolutely critical for biology, allowing essential nutrients and vital minerals to be efficiently transported throughout living organisms. On a planetary scale, water continuously dissolves and transports massive amounts of minerals, actively shaping geology and heavily influencing the ocean's complex chemistry. Furthermore, liquid water is virtually incompressible. Even under the crushing weight of the deep ocean, its overall volume decreases only very slightly. This incredible incompressibility is the fundamental principle behind powerful hydraulic systems, transferring massive mechanical force efficiently without losing energy to volume compression. Yet, another paradox exists here. Water's compressibility actually decreases as it warms up from freezing to roughly 46 degrees Celsius, highly unusual. At lower temperatures, the bulky, open hydrogen bond network contains more empty void space, making it slightly easier to compress under applied pressure. As it warms, this open network partially collapses, packing the molecules closer together, surprisingly making the liquid increasingly resistant to further compression. Returning to the revolutionary two-liquid hypothesis, Professor Anders Nielsen and his dedicated team have spent decades meticulously trying to unravel this profound mystery. They view liquid water as a fierce, continuous thermodynamic battleground between a highly ordered low-density structure and a chaotic, high-density structural arrangement. At normal everyday temperatures, the chaotic high-density structure dominates the mixture, but small fleeting clusters of the ordered low-density structure continually form and vanish. As the temperature drops significantly, these ordered low-density clusters grow larger and persist longer, fundamentally driving water's strange, anomalous physical behaviors. This increasing proportion of the spacious, bulky, low-density structure is the exact microscopic reason why water expands so dramatically as it cools down. However, proving this definitively is incredibly difficult due to a mysterious temperature zone known to physicists as the deeply supercooled no man's land. Between minus 41 and minus 113 degrees Celsius, liquid water is so intensely unstable that it inevitably crystallizes into solid ice almost instantly. This rapid crystallization presents the ultimate, frustrating barrier for scientists. How can you possibly observe and measure a liquid state that disappears so incredibly fast? This is precisely why the development of ultra-fast femtosecond X-ray lasers was a truly revolutionary, game-changing milestone for modern physical chemistry research. A femtosecond is 1/1,000,000th of a billionth of a second. These lasers flash so unbelievably fast, they can literally outrun the rapid freezing process. By utilizing this unimaginable speed, scientists finally managed to capture fleeting, direct snapshots of water existing in two distinct liquid states within no man's land. The data strongly hints at a sudden, dramatic structural shift, providing compelling evidence for the existence of the elusive, highly debated liquid-liquid critical point. At this theoretical critical point, the clear distinction between the two liquids completely vanishes, resulting in massive, chaotic, structural fluctuations throughout the entire substance. Physicists believe that the echoing effects of these massive, critical fluctuations are the true underlying source of all of water's bizarre anomalies at normal temperatures. It is a highly sensitive, incredibly complex system delicately balanced on a microscopic knife edge, constantly shifting and reacting to the slightest changes in its environment. The mystery deepens even further when we examine how water behaves when it is tightly squeezed into incredibly small microscopic spaces, known as nano-confinement. Inside incredibly narrow carbon nanotubes, water defies logic again, sometimes forming solid ice-like structures at temperatures well above its normal boiling point. The extreme physical confinement forces the water molecules into highly unusual, highly organized, single-file arrangements, drastically altering their fundamental thermodynamic properties. This is crucially important because almost all the water inside our bodies exists in a heavily confined state, tightly packed between massive, complex cellular structures. Biological water does not flow freely like water in a glass. It is significantly more viscous, highly structured, and intimately bound to biological surfaces. This specialized hydration layer acts as an essential, active lubricant, dynamically facilitating the rapid, complex folding and precise functioning of vital cellular proteins. If this delicate, structured water layer is severely disrupted, proteins can quickly misfold and denature, potentially leading to devastating cellular dysfunction and serious diseases. Understanding these profound microscopic secrets is not just abstract physics. It opens up exciting, revolutionary pathways for highly advanced water filtration and clean energy technologies. Engineers are actively designing new, incredibly efficient nanomembranes that perfectly mimic the highly selective, rapid water channels found naturally within our own biological cells. These advanced biomimetic membranes could potentially desalinate vast amounts of seawater with unprecedented, incredible efficiency, requiring significantly less energy than current industrial methods. In the critical energy sector, a deeper understanding of water's complex molecular bonds is absolutely vital for developing highly efficient, clean hydrogen fuel production technologies. By mastering the precise catalytic splitting of water, we could potentially unlock an abundant, entirely sustainable, and completely clean energy source for our future. However, to fully harness this profound potential, the scientific community must first definitively resolve the ongoing, intense debate surrounding the two-liquid state hypothesis. Some prominent, highly respected researchers remain skeptical, arguing that the complex data can potentially be explained by alternative, more conventional thermodynamic models and theories. They strongly argue that the incredibly rapid, chaotic crystallization process heavily distorts the delicate measurements, creating false, misleading signals that mimic two distinct liquid states. This vigorous, healthy scientific debate is exactly what continuously drives progress forward, demanding increasingly sophisticated, highly precise experiments and far more advanced computational modeling. Massive supercomputers are now being extensively utilized to run incredibly complex, highly detailed quantum simulations of millions of interacting water molecules over relatively long timescales. Recent results from these incredibly powerful, highly advanced simulations increasingly appear to provide strong, compelling theoretical support for the existence of the elusive critical point. The powerful, synergistic combination of cutting-edge X-ray laser experiments and highly advanced supercomputer simulations is slowly but surely unraveling this profound, enduring mystery. Our profound quest to understand water extends far beyond the confines of Earth, reaching out into the vast, mysterious depths of our surrounding solar system. Consider Jupiter's fascinating moon Europa, covered entirely by a thick, cracked shell of solid ice, hiding a massive, deep liquid water ocean beneath its frozen surface. Or Saturn's remarkably active moon Enceladus, which continuously erupts massive towering geysers of water vapor and tiny ice particles directly into the cold vacuum of space. The water hidden deep within these alien oceans exists under absolutely crushing extreme pressures, potentially exhibiting entirely different, highly exotic physical behaviors and anomalies. Studying the high-density structural state of water helps us accurately model and deeply understand these extreme, high-pressure environments found on distant, icy planetary bodies. The ultimate burning question remains: could these dark, freezing, high-pressure alien oceans possibly harbor their own unique, highly adapted forms of extraterrestrial life? If the water there maintains a robust, dynamic hydrogen bond network, it could potentially support the incredibly complex biochemical reactions absolutely necessary for life. Returning to our own vibrant planet, every single drop of ocean water is absolutely teeming with countless millions of microscopic organisms, the very foundation of the food web. Water provides the absolutely perfect, incredibly stable environment for life. An excellent universal solvent, a powerful thermal buffer, and a vital shield against harmful radiation. It is widely believed that the very first primitive sparks of life on Earth originated deeply within this incredibly dynamic, chemical-rich, primordial aquatic environment. And all of this incredible, life-sustaining magic ultimately stems from the simple yet profoundly complex, dynamic network of tiny, invisible hydrogen bonds. Every time it rains, we are directly witnessing a massive, global redistribution of this miraculous, highly anomalous substance that continuously sustains our entire living world. The continuous, never-ending water cycle of evaporation, condensation, and precipitation is the massive, powerful planetary engine that actively drives our complex global climate system. Even in its invisible gaseous state, water acts as the most significant, powerful natural greenhouse gas, critically maintaining Earth's comfortably warm, habitable average temperatures. Tragically, rapid human-induced climate change is now severely disrupting this delicate, highly complex global water cycle, leading to increasingly extreme and devastating unpredictable weather patterns. Massive ancient polar ice caps are rapidly melting at an incredibly alarming rate, severely threatening coastal communities worldwide with dangerously rising, encroaching global sea levels. Dangerous changes in ocean temperature and salinity could potentially weaken or even completely halt vital, massive ocean currents, like the critically important Gulf Stream. A deep, precise understanding of water's complex thermal capacity and intricate fluid dynamics is absolutely essential for creating accurate, highly reliable, predictive models of our future climate. We must urgently prioritize the protection and careful conservation of our clean, fresh water sources, recognizing it as our most precious, incredibly fragile, and highly limited resource. Every single drop of water you consume carries a profound, incredibly ancient cosmic history, originally forged deep within vast, cold interstellar dust clouds billions of years ago. Massive, icy comets and numerous water-rich asteroids relentlessly bombarded the young, barren Earth, violently delivering the vast, essential oceans that eventually fostered all known life. Water acts as a profound, universal cosmic messenger, silently carrying the incredible, fundamental potential for complex biology across the vast, unimaginable expanses of the universe. Back in the quiet, focused laboratories, dedicated scientists continue their relentless, meticulous pursuit of knowledge, constantly pushing the absolute boundaries of our current scientific understanding. They are actively designing new, unprecedentedly powerful X-ray lasers and advanced detectors to finally pierce the remaining mysteries hidden deep within the deeply supercooled no man's land. The ultimate, highly anticipated goal is to discover undeniable, absolutely conclusive physical evidence confirming the exact location and precise nature of the elusive liquid-liquid critical point. If definitively proven, this would undoubtedly rank as one of the most profoundly important and completely paradigm-shifting discoveries in the field of physics this entire century. It would forcefully require us to completely rewrite our fundamental textbooks on physical chemistry, complex thermodynamics, and the intricate molecular mechanics of all biological life. Furthermore, it would rapidly unlock a vast, unprecedented wave of revolutionary new technological applications across medicine, advanced materials science, and highly sustainable clean energy production. But regardless of the final, conclusive outcome of this specific debate, this incredible scientific journey highlights the staggering, profound complexity and sheer wonder of the natural world. Water, a substance that appears so incredibly simple on the macroscopic surface, actually conceals a staggeringly complex, highly dynamic, and beautifully intricate universe deep within. It serves as a powerful, humbling reminder that the scientific endeavor is never truly finished. There are always profoundly deeper, more complex layers of reality waiting to be uncovered. Insatiable human curiosity remains the ultimate, powerful driving force, propelling us forward, relentlessly compelling us to decode the deepest, most profound mysteries of our vast, complex universe. From the tiniest, most delicate morning dewdrop to the most massive, unimaginably powerful, churning global oceans. Water intimately and powerfully connects absolutely everything on this vibrant planet. We must learn to deeply appreciate, thoroughly understand, and fiercely protect this miraculous, highly anomalous substance that makes our very existence and all complex life entirely possible. To summarize our journey, we've explored water's bizarre, life-saving density anomaly, its immense thermal capacity, and the highly revolutionary paradigm-shifting hypothesis of two fluctuating liquid states. The continuous, chaotic, microscopic dance between a high-density and a low-density structural arrangement appears to be the fundamental underlying key to explaining almost all of water's bizarre paradoxes. We have also seen how unprecedented cutting-edge technologies like ultra-fast X-ray lasers are absolutely crucial for pushing the extreme boundaries of our current physical and chemical knowledge. And finally, we have highlighted the profound, undeniable, and deeply intimate connection between water's highly complex microscopic structural dynamics and the grand macroscopic flourishing of all biological life. Water is not merely a passive, inert background solvent. It is the highly active, absolutely essential, and incredibly dynamic lead actor in the grand, complex theater of life. As we conclude this deep dive into the profound mysteries of water, we hope you have gained an entirely new, deeply profound appreciation for this seemingly simple, everyday substance. The next time you gaze upon a calm, reflective lake or a vast, powerful ocean, remember the incredibly complex, highly dynamic, invisible, microscopic universe actively churning just beneath the surface. We invite you to continue exploring the fascinating, endless wonders of the natural universe with us. There are always more profound mysteries waiting to be uncovered and thoroughly explained. What other bizarre natural anomalies or complex scientific paradoxes absolutely fascinate you? Share your profound thoughts and eager questions in the comments section below this video. Our fragile, beautiful blue planet is an incredibly rare, highly precious oasis of liquid water floating in a vast, mostly cold, and deeply hostile cosmic void. Understanding its deepest, most profound secrets is the very first, absolutely crucial step towards truly protecting it and ensuring the continued flourishing survival of all complex life. From the very smallest, newly sprouting seed to the most massive, ancient forests, absolutely everything depends entirely on the unique, highly anomalous, and deeply miraculous properties of water. Life always relentlessly finds a way to adapt and thrive, and liquid water is the essential, highly complex, and deeply fundamental pathway that makes that incredible resilience entirely possible. Thank you so much for joining us on this incredibly deep, highly fascinating scientific journey into the profound, complex, and enduring mysteries of the world's most vital liquid. If you enjoyed this deep dive, please remember to subscribe to our channel and hit the notification bell so you never miss our future, highly detailed scientific explorations. Click on the videos currently on your screen to continue exploring the vast, incredibly fascinating universe with us. From massive black holes to the search for alien life, nature is vast, incredibly complex, and deeply awe-inspiring. We are merely at the very beginning of our long, profound journey to completely understand its deepest, most hidden mechanics. Science acts as our brightest, most powerful, illuminating torch, constantly guiding humanity forward through the vast, intimidating darkness of the unknown towards greater, more profound understanding. Let us continuously keep asking profound questions, relentlessly challenging our deeply held assumptions, and actively seeking out the complex, hidden truths that govern our fascinating, intricate reality. Water will always be there, flowing continuously through our world, patiently waiting for us to eventually uncover its remaining, most deeply hidden and profoundly complex structural secrets. It is a truly incredible, deeply inspiring journey of continuous discovery, proving that even the most common everyday things can contain the most profound, universe-altering scientific mysteries imaginable. The profound beauty of water is not just in its stunning visual appearance, but deeply embedded in the elegant, highly complex, and completely miraculous physics that govern its existence. Always keep your profound scientific curiosity burning incredibly bright. Never stop deeply questioning the complex, fascinating world that surrounds you every single day of your life. You have been watching Video Creator. We are deeply committed to bringing you the highest quality, most fascinating, and profoundly educational science documentaries available anywhere on the internet. Please follow us on all our social media platforms to stay completely updated on our latest, highly detailed research and upcoming deeply fascinating video documentary releases. A very special, deeply heartfelt thank you to all our incredibly generous Patreon supporters and channel members who make these highly detailed, deeply researched educational videos entirely possible. Your vital support directly helps us continue to produce high-quality, profoundly educational content and actively inspires the next brilliant generation of dedicated, passionate scientific researchers and explorers. As we finally draw this extensive, deeply detailed exploration to a close, we want to leave you with one final, profound, and highly fascinating thought regarding this miraculous liquid. Within every single tiny drop of water lies an incredibly vast, highly complex, and profoundly mysterious universe of physics that we are only just beginning to truly understand. It is a profound testament to the incredible, staggering complexity and sheer, breathtaking beauty of the natural universe that surrounds us and actively sustains our very existence.